Okay, here's example 1.84. I'm solving, really what I'm trying to do is find the inverse of this function. And I wanted to talk about this example because it's kind of subtle. There's some pretty tricky things, kind of expert level stuff going on in this problem. And maybe, I mean, your book does address it all. Your book didn't miss anything. It's all right here. But I think it's a little bit hard to understand this or to understand how important all this verbiage is here. So I'm going to try to talk you through this thing. So the first thing is just kind of go into it naively, I suppose. Find the inverse of this function. Well, I got a function. I can find the inverse. I remember that. I'm supposed to change the f of x into a y because it's easier to do algebra with letters like x and y. Fine. And then if you're following the way I do this, at this point you switch the x's and the y's. Your book waits a little while to switch the x's and the y's. It really doesn't matter. Do it whenever the hell you want. I like to do it right off the bat so that I have an equation that represents the inverse function. I feel like that's a step in the right direction. And then just solve this equation for the output so it's in function form. Subtract 2 from both sides of the equation. Solve for y, so I got to get rid of this pesky square root, so I'll square both sides. X minus 2 squared equals y minus 4. So I can get y all by itself if I just add 4 to both sides of the equation. Get something like this. Perfect. Oh, no, I'm not done. I'm supposed to rewrite this in function notation, which maybe your teacher doesn't even care about. Maybe he does, he or she. Get f inverse of x equals x minus 2 squared plus 4. Cool. Here's the inverse function. Here's the function. Here's the inverse function. Awesome. I'm done. Actually, you're not. Something strange happens here. Check this out. F inverse, maybe I'll write it down here. Let's find f inverse of, I don't know, 0, for example. F inverse of 0. Here's a function. It's an inverse function, but fine. It's a function. I can put 0 into it. I got an equation for the inverse function, so let's put 0 into it. I guess I would just copy this as my blueprint, except change all the x's into zeros, and I get 0 minus 2 squared plus 4. But 0 minus 2 is negative 2, and negative 2 squared is 2, and 2 squared plus 4 equals 8. So f inverse of 0 equals 8. Yeah, not that exciting, but okay, I guess that's right. If f inverse of 0 equals 8, then what, I ask you, would f of 8 be equal to? F of 8 equals 0? Right? If the input in the inverse function is 0 and the corresponding output is 8, then what that should tell me is that if I take 8 and put that into the function, 0 should come out. Is this true right here? It should be, right? Based on what I know about inverse functions, this should be a true statement. But based on the way my inflection and the way I'm asking this question and the point that I put a fat question mark right here, you might think it won't be. Well, let's see what happens. Here's my function. I can figure out f of 8. Just copy this thing right here. And everywhere you see an x, change it into an 8. 2 plus the square root of 8 minus 4. Uh-oh. 8 minus 4 is 4. The square root of 4 is 2. 2 plus 2 is 4. F of 8 does not equal 0. Wait, what happened there? F inverse of 0 equals 8, but f of 8 does not equal 0? It seems like something went wrong. So go back and check these steps. We must have made some algebraic mistake or something. No, we didn't. What happened here is that this function, the range of this function, does not include all numbers. I cannot have all possible numbers come out of this. Okay, let me prove that to you. I can graph this function because it's really just transformations of one of my toolkit functions, right? The square root of x, I know that that looks like this, roughly speaking. And this is going to shift it up 2, and this is going to shift it to the right by 4 because I'm going to subtract negative 4 from each of the x coordinates. I'm going to add 2 to each of the x coordinates. Subtracting negative 4 is the same as adding 4. At any rate, the point that I'm getting at is f of x, the graph of that thing, would look something like this. And then maybe that should have been into a different color. And now you can't see it at all, but whatever. Here's the graph of the function. All possible numbers cannot come out of this function. It is not possible for any height below 2 to come out of this function, right? 1 can't come out of this function in red. There is no height of 1 corresponding with an input in red here on this graph. The range of f is numbers from 2 to infinity. And the range of the function is the same as the domain of the inverse function. So this is algebraically correct. However, It's only true for values of x that are greater than or equal to 2. This machine right here is only the inverse of this machine if I restrict the domain of this machine to values greater than or equal to 2. Otherwise, I'll get strange results like I did here. The reason I got a strange result here is because I tried to put 0 into the inverse function, and I shouldn't be putting 0 into the inverse function. The inverse function should only accept values that are greater than or equal to 2. And the reason that's true is the range of the function can only output values that are greater than or equal to 2. So because you can only output values that are greater than or equal to 2 from the function, you can only input values to the inverse function that are greater than or equal to 2. So to be correct here, you have to include this statement right here. And now anything that I put in here, everything will work out nicely. I won't come into weird counterexamples like this. This happens anytime you have these radical functions. When you're trying to find the inverse of a radical function, you have to be really careful about the domain. And you'll always want the domain of your inverse function to be equal to the range of your original function. And fortunately for you, you can figure out the range of the inverse or the range of the original function pretty easily. Just think about it in terms of transformations. But really, the fact that I shifted everything to the right by 4 doesn't matter at all because I'm just trying to figure out the range of my original function. And the range is the possible outputs. And the range of the original toolkit function, the square root of x, is everything from 0 to infinity. And if I shift everything up by 2, it's now everything from 2 to infinity. Whether or not I shift it left or right is completely immaterial. Only this 2 ended up mattering. I guess that's all I have on this example. I'll do this, try it next to talk more on this stuff because I think it's a hard topic for people to grasp.